Hi, I'm Heather.
Hello, I'm Olivia. We are going to be focusing on Physical World Stage 3, specifically looking at contact forces and Newton's third law.
Our physical world outcome is investigate the effects of increasing or decreasing the strength of a specific contact or non-contact force. Our digital technologies outcome is plans and use materials, tools and equipment to develop solutions for a need or opportunity.
Firstly, in the engage phase, we ask the question, how does a rocket work? We use the NASA website and rocket stimulation to explore how a rocket takes off, what makes a rocket travel further, and what forces are involved. You then drew how you thought a rocket worked and labelled the forces. During the explore phase, we were introduced to Newton's third law. For every action, there is an equal and opposite reaction. We explored this through the demonstration of standing on a skateboard and throwing a medicine ball. The medicine ball moves forward and the person gets pushed back on the skateboard. As the person is heavier than the 6-kilo medicine ball, the ball travelled further. We also explored friction by testing how far skateboards could move on different surfaces, including concrete, grass, and a rug. Finally, you use the skateboards to explore in groups these questions related to skateboards. If you stop kicking, the skateboard will stop. Can you explain why? And the skateboard is not moving and the ground is flat. What forces might there be on the skateboard? In the explain phase, we rubbed our hands together to notice how friction makes our hands feel warmer. We used the PhET stimulation on friction to write an explanation of what friction is. We discussed what forces were involved in the skateboard moving and stopping, including gravity and friction. As a class, we discussed how Newton's third law explains how both balloons and rocket engines work. The action of air rushing out from the neck of the balloon pushes against the balloon, moving it in the opposite direction. Rocket fuel produces hot gases that are forced out of the back of the rocket, and the gases exert an equal and opposite force on the rocket that pushes the rocket upward. In small groups, you created a poster of your understanding gained from your own exploration and our class explanation. You demonstrated your understanding of Newton's third law, how friction stops the skateboard from rolling forever, and any other understanding that you have gained about forces.
During the elaborate phase, we'll be conducting an experiment looking at force and speed and the relationship that those two have. We are specifically focusing on Newton's third law and friction. The experiment we will be conducting is a balloon rocket experiment. Our hypothesis is, if the string is rough and thick, then the balloon will travel slower along the string due to an increased friction. Our independent variable is the string, as that's what we will be changing. Our dependent variable is the speed. Our controlled variables are the type of the balloon, the length of the string, and the amount of air in the balloon. The materials needed to conduct a balloon experiment include an iPad, 3 different types of string, balloons, straws, scissors, and sticky tape. We'll be using 2 different applications on the iPad during our experiment. The first is the Measure app to measure the lengths of the string and the straws. The second app we'll be using is Speed Clock. Speed Clock measures the speed of an object moving, and we'll be using this to record the speed of our balloon. The first step in our experiment is to measure out a piece of string using the Measure app. You then need to repeat this for the fishing line, the cooking string, and the wool. Once you have successfully measured 4 meters of string, you then need to mark and cut the string. The next step is to use the Measure app to measure the length of a straw. Once the length of a straw has appeared, a halfway indicator will then appear on the straw. Use a permanent marker to do a dot on this halfway point, and then use the scissors to cut the straw in half. The next step is to obtain the balloons and sticky tape. You then sticky tape the straw to the balloons. Your balloon rocket is now ready to roll. Our first trial of the balloon rocket was on a fishing line. We hypothesized that this would be the fastest as it is the thinnest string that we will be using. We then used the Speed app to record the speed of the balloon travelled along the string. The next balloon travelled along a cooking string. We hypothesized that this would be the second fastest. We followed the same steps and then used the Speed app once again to record the speed of our balloon. The final string we used was a piece of wool. We hypothesized that this would be the slowest. Repeating the same steps, we then used the speed app to record the speed of our final balloon. It was then important that we repeated this experiment at least 3 times for reliability. After completing our experiment and using all 3 of the string types, our hypothesis was correct that the fishing line caused the least friction, as the balloon went the fastest. Throughout this process, we also used the Science Journal by Google to document our experiment. We documented our results by adding a post for each of our different string types. We also added in our observations, and then we collated these observations into a column graph. When conducting our experiment, we also noticed that the tension on the rope affected how fast the balloon travelled. We then drew our conclusions.
For the evaluate phase, we marked their science journals as we read the observations that they had added, the graph that they had created based on the results, and also the conclusions that they'd written up. Then as a class, we developed our whole class conclusion, and their contribution to that discussion was also marked as part of the evaluate phase. So as a class, the conclusion that we developed was that the effect of increasing the strength of friction on the balloon decreased the speed that the balloon was able to travel along the string. Based on that, it is clear that the fishing line had the least amount of friction, as the balloon could slide across it at an increased speed. The friction of the cooking string wasn't too far behind the fishing wire based on the speed, but the wool was the slowest by far. Therefore, it demonstrated that the friction of the wool was much higher than the fishing line and the cooking string.